Hi, my name is Gayathri, and my project for pattern recognition project is implementation of voice recognition using discrete Fourier transform. Pattern recognition is that process of assigning a label to some input and making a system recognize it. So the project I have taken up is voice recognition. Voice recognition is actually the process of finding the speaker who speaks. This is done by matching the keywords that the speaker speaks and also the voice of the speaker. So, the main reason for coming up with voice recognition is privacy, because privacy has become one of the most important concerns when it comes to electronic technologies these days. Um, it has to be seen that the safety in accessing the devices and memory components always need a proper recognition technology to maintain the security and privacy. One of the earliest techniques which have been used to maintain the privacy of a system is keeping a password. It holds good even these days. And other technologies which have been used are face recognition, gait recognition, fingerprint or handprint recognition, voice recognition, iris or retina recognition, DNA recognition, etc. And also, apart from the point of privacy, um, voice recognition is also being used in data mining, data analytics, artificial intelligence, etc. Um, Voice recognition is basically done in two commonly used techniques. They are template matching and feature analysis. Template matching is found to be the easiest approach and very accurate. Um, the traditional method of template matching starts by making a user speak into the microphone. So, whenever he speaks it, the electrical audio signal is being converted to a digital form using a analog to digital converter. This digitized voice input is being stored in a memory. Now, a computer should find out what has been stored, and the input audio given by the user has to be recognized by the computer. So in this technique, what will be done is that the digitized input will be compared against a template which is being already present in the system. So this is literally matching of template. But this is practically not possible, because if there are going to be a lot of user inputs, then there has to be a lot of templates that has to match the multiple users. So this system is speaker dependent and not really practical. So to overcome this hazard, the system has to be designed in such a way that whenever new users come to try the voice recognition, their voice has to be uh, familiarized by the computer. So the computer has to be trained to recognize their voice. The other technique which is used for voice recognition is feature analysis. So in this process, the voice is being analyzed in frequency domain. So first step of this method is converting the voice input into frequency domain by using a discrete Fourier transform in our case. Once when it is being converted to frequency domain, the spectrum of the frequency of the voice samples will be compared, and we'll get to know the user. So what it actually does is that it will find the similarities in characteristics between the inputs that have been digitized and the set of expected inputs. So even while using these two technologies, the common problems faced in voice recognition are that there are a few parameters which will change as a person speaks. That is, the speed in which he speaks, the way he speaks, the intonations, that is, the tone may go high or low, and the modulations, that is, some words may be overemphasized, some words may be silent, and all that, and also the volume in which the person speaks. These parameters keep varying along a speech. The other problem which is faced is homonyms. Homonyms are the words with uh, different spellings and different meanings but similar sounds. So when you set one word as a keyword or a phrase and its homonym is being said by another person, then it is not foolproof. So the voice recognition fails there. Another challenge in voice recognition is that people have different accents and people are from different parts of the world. They are from different countries. So they might pronounce the same word in different ways. So there has to be a technique in order to overcome this accent issue also. So as I said, in frequency domain of feature analysis technology, the frequency spectra of different voice samples will be compared. So to do that, we use a DFT technique to convert all the digitized input to frequency domain. If we are going to analyze it in the time domain, all the voice samples has to be started in the same time, which is a problem. So frequency domain analysis is always better. Also, since we are doing the voice recognition for humans, their voice range is lesser than 600 hertz. So all the frequencies above 600 hertz can be easily avoided. Now, once the voice samples are being converted to frequency domain, they are assumed to be vectors in the Euclidean space. So these vectors are then normalized and then they have been used to calculate the norms. When the norms are calculated for different voice samples, we can see that the difference between those norm frequencies will help us to determine the user. So if the difference between the norms of different voice samples is very less or almost zero, then it means that those voice samples are from the same user and vice versa. The other concept which has been used after DFT is that Chebyshev's inequality. According to his theorem, it states that if there are a set of values, then 3/4 of those values always lie within plus or minus 2 standard deviations of the mean of the values. So when we apply the same concept here, if we have n number of samples, voice samples, and we find a mean, then always at least 3/4 of the times the voice recognition will be correct. So 75% accuracy can be achieved. In order to implement this, we have tried MATLAB coding and I used two codes, one for actually recording the samples from the user and another for performing the DFT normalization and the frequency comparison. So let us see those files now. Initially, I begin this with recording of the samples. So what this is going to do is that I will be given 2 seconds to say a name which will be recorded for 10 times. I have chosen n equal to 10 here. So I'm going to run it. So let me begin. Gayatri, 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 Gayatri. So now I have recorded my name as 10 voice samples and now the system knows my voice and knows that my keyword is Gayatri. Now I am going to run the other MATLAB code which will actually perform all the voice recognition algorithm. Now the computer has learnt my voice but it needs a name for my voice. So it has asked me the name of the user that has to be recognized. So I am writing my name, Gayatri, and now I have 2 more seconds to say my name. Now the voice which it already has, the voice samples it has, the computer knows that Gayatri has given the 10 voice samples, and now it is going to take one more sample and see if it is the same Gayatri. Gayatri. So the recording has come out well. I'm just going to proceed. So it says hello Gayatri. So what the system has done is that it knows that these 10 samples belong to Gayatri, and once it got the name, it tried to make me speak again and compare with these 10 samples, and it now knows that they match, and so it has recognized me as Gayatri. So this is how the voice recognition software works, and also the frequency spectra comparison has been drawn out, and this is how it looks. So you can see that there is not much difference of this frequency spectra of different voice samples, so it means it's the same user. So ultimately this is the aim of the project, and the text has matched with the voice, so it said hello Gayatri, which is what we wanted. So the voice recognition has been successfully done, and these are the references which I have used. Thank you.